So let's say you've got a quadratic in standard form and you need to graph it. So you have a few options. You could make a table of values, you could convert it to vertex form, or you can convert it to factored form, or some combination of those things. So let's practice this up real fast. To get from standard form to vertex form, that's completing the square. And lots of ways to do that. The way I like to do it is to get rid of this leading coefficient of 2 by dividing both sides by 2. And that just makes things a little easier on this side. I'm going to continue working with y over 2 on the left. And here I want to take half of this value and then square it, so that'll be plus 9, and then subtract the same value, minus 9 plus 8 at the very end. So y over 2 is, this is now x squared minus 3, x minus 3 all squared. And then here I have minus 1. Now I can get rid of that 2. Multiplying both sides by 2, I have 2 times x minus 3 squared, and here I've got minus 2. All right, that's my vertex form. I'll write that up at the top here. 2 times x minus 3 squared minus 2. I know the vertex then is positive 3, negative 2. Okay, let's go to the factored form, starting with the same complex trinomial, except that once again I've got that 2 there that I can factor out of each term. So again I'm going to go y over 2 equals, and that leaves me on this side with x squared minus 6x plus 8, and that's pretty easily factorable. Y over 2 equals, I can kind of do that one in my head, two numbers that multiply together to give me 8 and add to give me negative 6. Well, they must both be negative. Negative 4 and negative 2 fit the bill, and getting that 2 back leaves me with that. So let me write that up at the top here. Y equals 2 times x minus 4 and x minus 2. Okay, well, let's look at graphing this. First of all, I know where the vertex is, positive 3, negative 2. So let me just go over here. I'll call this positive 3, and that's negative 2. So there's 3, 6, negative 3, negative 6, negative 3, negative 6, and going up, there's 3 and 6. Okay, so there's my vertex, 3, negative 2, and this guy opens up because it has a positive number in front, and the coefficient in front of the x squared term is 2, which means I could use my step pattern and just double everything over 1 up 2, over 1 up 6, and so on. What I want to point out, maybe I'll do that. I'll first do the first couple of points, one on each side. I want to point out in the factored form I can read this as well. If you use the factored form here, in order to intercept or intersect the x-axis, that happens whenever y equals 0. That's what that means. That's what the axis is for. And so if y equals 0, that would mean that 2 times x minus 4 times x minus 2, using the factored form, that equals 0. Well, I have 3 numbers, 1, 2, 3, all multiplied together, and the final answer is 0. At least one of these things must be 0. I know that this is not 0 because it's 2. This could be 0, or this could be 0. So just to write that down, x minus 4 equals 0, or x minus 2 equals 0 in order for y to be 0. One of these 3 things has to be 0 because they multiply to 0. Maybe more than one of them, but at least one of them. This one can't be, so it has to be one of these 2. And these 2 are different numbers. These are easy to solve. X minus 4 equals 0. That's x equals 4. Or x equals 2. Where does y equal 0? When x equals 2 here, or x equals 4. So I can get these points by reading the factored form. If I want to use my step pattern and continue up here, I can continue to graph this parabola using what we know already. we'll just finish this off here. Okay, these values here, x minus 4 equals 0, so x equals 4 or x equals 2, these are called the roots of the quadratic or the zeros of the quadratic. So these can help you graph as well if you can factor the thing. If not, you can always rely on the vertex form and then that step pattern to count things. I hope that helps, and ask me some questions.